So this is math in the morning. There's a circle, yeah. Now this is x-axis, y-axis, origin is center, and say this length is, let's say 4, yeah. So the equation of this circle is x square plus y square is equal to 16, which is 4 square, yeah, 4 square, 4 square. Now when shifted, the center to a place, say here, okay, so it goes h to the right and k vertically, and you have a, let's just say a bigger circle, okay, with radius 7. Then this equation would be x minus h whole square, because it shifted to the right, plus has to be actually y plus k. See, y minus k whole square is equal to 49, which is 7 square. Let me just think about this. Now this goes to the right, so it is negative. Goes to the top, it is positive. Yeah, it's a bit of a complication because probably because of the squares. This could use some research, because there seems to be a bit of an anomaly in my mind about how the equation of a circle, this is the equation of a circle with center HK, this is the center HK, how this equation of a circle with radius 7, 49, 7 square, radius 7, how this relates to translating a circle, let's just say radius 7, with center as origin, where HK is 0, if you notice, to the right and top. But let's leave that at that and just keep the equation of a circle with radius 7 and center HK as this. Now I was thinking about how the center of a circle is written as HK, which can be thought of with y's, and notice the ij's between the h and k's, which I is actually an imaginary number, not in this context. Sort of a switched context is square root of -1, and I square is equal to -1. Think of I as imaginary complex numbers, where the square root of a negative number is not real. You can't have two numbers, as in one number multiplied by itself, x times x, giving a negative number, because negative times negative is positive, right? So, and positive times positive is positive. So you cannot have two real numbers multiplied one real number multiplied by itself. Let's think of it like that and get a negative number. But imagination is often creation, and from that comes I, the world of complex numbers, imaginary numbers, where, for example, square root of, say, minus 25, yeah, is equal to square root of minus 1 times 25, which is square root of minus 1 times square root of 25, which is I, this bit is I, yeah, square root of minus 1 is I, and 25 square root is 5, so minus square root of minus 25 is equal to 5i. The I is written after the 5 as a convention. 5i, which is an imaginary number, complex number. Then there's the j between the h and the k, which is kind of like a unit vector where I have x-axis, y-axis, and unit vectors are often represented as I with this sign. So you would want to think of a unit vector as for something in the direction of the x-axis with magnitude 1. So unit 1, vector, I, direction. Vector scalars, vector. You would want to think of a vector as a car moving in a certain direction, yeah? Direction. Like think direction, think vector. Now, something just moving wherever, where the direction doesn't matter, is a scalar, only magnitude, weight. Well, weight technically is a vector. It has direction. Mass is a scalar. So, okay, that's a tangent technicality. Let's spend a little time with J and wrap up for today. In Freeflow math, freestyle math, the J is the unit vector in the y-axis direction. Unit vector 1, magnitude 1, vector direction, and this time the direction is on the y-axis. That's the J bit. I with this sign is the unit vector in the x-axis direction, and there's actually a k also, unit vector k, which is a 3-dimensional situation, z-axis unit vector. That's that, yeah. Complex is better thought as imaginary. And I is square root of minus 1. I square is minus 1. One video for today. Pleasantness for you too. Yay.